These are the notes for LT7, which is the final learning target in the sound and wave unit. And the target says that you can describe how a shock wave leads to the phenomenon of a sonic boom. All right. Along with this target, or just prior, you do a gizmo, and in that gizmo, it's actually a Doppler effect gizmo, but at some point, you have a jet that is out running its sound waves. And we modeled that in class, and we see that as a three-dimensional figure. All right, so that three-dimensional conical figure, C-O-N-I-C-A-L, that's what, so cone-shaped, is the actual shock wave that gets produced. So it's three-dimensional. When it strikes the ground, we hear this is a sonic boom. Now, there's a misconception that a sonic boom has to be made by a jet. All right, but if you think about like a bullwhip or a horsewhip, and you've seen people that can just like flick that thing in the air, and they're not hitting any animal, but they can flick it in the air, and they can get that crack, that real loud noise. That's actually a sonic boom. Right? That's a way that a sonic boom can be produced. There are people that can take like a towel, and you wind up the towel and you snap it in the air. You get a little crack. Right? That's a sonic boom. Bullets leaving a gun, a lot of times bullet velocity is greater than the speed of sound, so that also creates a sonic boom. Something's important. Within this unit, a lot of prefixes cause a little bit of confusion. Ultra and infra. If you were to Google what does ultra mean, that means like above or beyond something. If you were to Google infra, it means below something. Super means it exceeds something, right? In elementary, we all get super on our papers and the cute little sticker because times are fun then, right? So we've got to think about these if we put the word sonic behind it. So ultrasonic, remember, that was a frequency above 20,000 hertz. Ultra means above. Infrasonic was a frequency below 20 hertz. Infra means below. Now, supersonic means exceeding. So we are exceeding the speed of sound when we say that something is supersonic. So here we go. Supersonic, defined, means faster than the speed of sound. All right, faster than the speed of sound. In air, we're just going to estimate here because it depends on the air temperature, which would altitude, things like that would determine density. So right around 340 meters per second. It's hard for us because we don't use the metric system in the United States very much, at least. So that would be about 761 miles per hour. So you're not going to go pick a car off the Ford lot or the Chevy lot or the Toyota lot and break the sound barrier, right? Cars aren't going to exceed the speed of sound. Now, it's going to be really important that you are motivated enough to go to Moodle and watch the Sonic Boom video clip. So look for the LT7 Sonic Boom Shockwave video clip, because a lot of these these drawings are not going to make much sense unless you go through and you've looked at that video clip and you participate with that Doppler effect gizmo, all right? The way we're going to represent a sound source is just with an S. So that means something is making the wave. So it could be a car at rest. Maybe there's a car out in the parking lot steadily laying on the horn. So the person's got their hand on the horn, they're not letting up. If you were to be able to see those sound waves, so there's the car that's beeping its horn. It's parked, okay, it's not moving. You would see a similar effect as if you dropped a pebble straight down into like a calm lake. You would see these waves spread outward, and the wavelengths are supposed to be perfectly equal. You know how that goes for me. But you would see perfect what I call concentric circles that would spread out. Now the amplitude would diminish the farther you got from the source. They would get quieter, okay? If you drop the pebble in, the waves would be less tall as you got away from the source. But frequency, pitch, that doesn't change because that's a wavelength thing. So if you see a picture like this, you know that the speed of the source is 0. And on the gizmo, you can set the speed of source to 0. Any frequency you want, click play, and you see those waves travel outward, equal wavelengths all the way around. Okay, so we know that this object is stationary. Stationary means not moving. All right. So obviously this is not going to create a sonic boom. Now what happens as an object starts to reach the speed of sound? So if you have a jet that is going exactly 340 meters per second, let's say, okay, so that's going to be the speed of sound. What you will start to see is the tip of that jet, and we're still going to call it the source, reaches and compresses the waves. All right, so you see these waves start to bunch up. All right, it's due to a air pressure thing. It's like it is compressing all of these waves. So here we go, and they are building up at the tip of the jet. Go to YouTube, type in sonic boom in physics, not just sonic boom. Who knows what craziness you'll get? But you can see some real footage, and if you are in class, you know we do this, where you can see like a cloud almost form at the tip of the jet. That's what is referred to as a wave barrier. And in common everyday life, we call that the sound barrier. All right, a lot of people, when I was a little kid, heard about, oh, it broke the sound barrier. What in the heck is this barrier? There's no wall in the sky. It's this pressure that's built up. It's the condensation and everything that's up in our atmosphere. And all of a sudden, it's pressed right to the tip of the jet. And so this object, when you see it's right, the tip of the jet, let's say, is right at this wall, so right at the tip of that cloud that you would see, that is how you know that the source is traveling at the same speed as its sound waves. Okay, so it's traveling at the same speed as its sound waves. So at this point, we don't get a sonic boom yet, but we have started to develop this three-dimensional cone. When the object has exceeded the speed of sound, here's the source. Let's pretend it's that jet. It's going to leave behind that conical cone. So here's your wall, right? So it has left it behind now. And that is ugly, but you get the idea. When that cone strikes the ground, okay, so we've got a person, let's say right here. So here they are on the ground. When that cone strikes the ground, this person has seen the jet go by. They don't hear it here. Okay, there's nothing to hear right here. But as the compressed air reaches the person, so once this part of the wave strikes the ground where this person is at, they hear one continuous tone, right? It's not a compression or rarefaction, a compression. It's one big crack. All this gets pushed together. And this three-dimensional wave is called a shock wave. Right. When it strikes the ground, when we get this whole three-dimensional thing going, that is what is called a shock wave. So when you hear about earthquakes, those are three-dimensional within the earth. It's the same sort of situation. Right. Maybe, not saying those waves are supersonic, but due to the shifting of the plates and all that, they generate a shock wave. So what we know here is that the source is greater than 340 meters per second. It has exceeded the speed of sound. It is now officially supersonic. Okay, it has to be going faster than the sound waves that it creates. Alright, I don't want you to get this confused with something else that most of us see, especially in the summer. Because that's not very good, I will label it. That is a boat. Most of us have traveled on a boat at decent speeds, and so you know that behind you create the wake. And that you might think is a shock wave, but it's not. It's two-dimensional. So behind a boat, I know it's going to look similar. That is only a two-dimensional wave. That is called a bow wave. All right, so your boat is not breaking the sound barrier. Okay, that would be one heck of a boat. So again, it's really important that you look at the Doppler effect gizmo because you model these when the jet is outrunning its sound waves. It's really important that you go to Moodle and click on the TED Talk about shock waves and sonic booms. And then I would just go to YouTube and just look for some real pictures, just some, maybe from air shows, whatever, of something breaking the sound barrier. Remember, it doesn't have to be a jet. And sorry for that announcement, but we're all set.